Okay, so in the previous lesson, we take a look at how to calculate the volume of gases using volume. Then for gases, reactions with only gases, we can straight away use volume ratio. So volume ratio and mole ratio, they are the same, or rather they are proportional. Okay, so this is only for gases. Okay, so recap, okay, stoichiometry is to take a look at the balance equation, and using ratio, we can find out from one substance, okay, the mass of one substance to identify the mass of another. Okay, so from here, we learn that this is the balance equation, and then the mole ratio is 2:1, is to 3, is to 1 small. Okay, so for example, if I want to make 3 smalls, okay, if I want to make 3 smalls, alright, using this balance equation, mole ratio, I will need 9 of my chocolate squares, so I times 3, and then 3 marshmallows. So the question can ask you, so what is the number of cracker squares I need to make 3 smalls? So from mole ratio, you know that they are all multiplied by 3, so the answer is 6. Okay, so this is what stoichiometry is all about, using mole ratio from balance equation. Okay, moving on, okay, we take a look at for gases, they are special. Okay, since Mr. Avogadro say 1 mole of any gas occupies 24 dm cube, okay, we know that mole is proportional to volume. Okay, so instead of mole ratio, we can use volume ratio for gases. So let's take a look at this video to see how volume is proportional to the mole ratio. So here in this equation, we see that it's 1 mole of methane reacting with 2 moles of oxygen, and then you produce 1 mole of carbon dioxide. So we only look at the ones that have the same state symbols. Okay, so for example, if my methane is 10 cm cube, okay, I will need 20 cm cube of my oxygen, and then I will produce 10 cm cube of carbon dioxide gas. Okay, so take a look at this short video.
This demonstration shows the explosive nature of stoichiometric mixtures of flammable gases. It can be used during lessons on combustion, hydrocarbons, and Avogadro's law. I use it most commonly in lessons on balancing equations, when it is a reward for students who have correctly balanced the equation showing the complete combustion of methane. As an extension, for those students who already know about Avogadro's law, you could use it as a challenge to ask them where the expansion comes from, as 3 moles of gaseous reactants produce 3 moles of gaseous products. In order to use the methane rocket experiment, we recommend that you use a strong plastic bottle of approximately 300 to 500 centimetres cubed capacity. A carbonated drinks bottle is a good example of a strong bottle. First, you need to find the exact volume of the bottle. And then you should replace exactly 1/3 of the water into the bottle and mark this level on the outside of the bottle using a waterproof pen. Replace a further 1/3 of the volume of the water into the bottle, and again mark the level on the outside of the bottle to indicate 2/3 of the capacity of the bottle. Finally, completely fill the bottle with water. Now you are in a position to displace 2/3 of the volume of the bottle using oxygen, and 1/3 of the bottle using methane. The oxygen supply could be from an oxygen cylinder or from a canister of oxygen which is easily available on the internet. Ensure that air is displaced from the delivery tube before starting to collect oxygen in the bottle. Again, ensure that air is displaced from the delivery tube before starting to collect methane in the bottle. You should then secure the neck of the bottle using a rubber bung. Ready for detonation. It's essential that the demonstrator wears ear and eye protection.
So we are done with the volume of gases, and we are done with the calculations for all types of reactions. Okay, the next part is volumetric analysis. So if you see the name volumetric analysis, it means that we are using volume to analyze. Okay, we are using volume to analyze. So let's take a look. Okay, so since we are using volume to analyze, okay, we are not looking at gases. Okay, we are not looking at gases. Okay, we are looking at volume of solutions and they are in aqueous state. So when they are in aqueous state, okay, let's recap this portion here. Concentration of solution. Okay, we are using concentration of solution. Okay, so what is volumetric analysis? Okay, volumetric analysis is to use volume of a solution with known concentration to analyze the concentration of another solution. Okay, so which means that we have one solution. For example, I have this solution of NaOH. Okay, I don't know what's the concentration. Okay, but I know that this volume is 25 cm cube. So inside this flask, there is NaOH. Okay, but I don't know the concentration. So I don't know the amount inside. Okay, I don't know the amount inside. But I only have the volume because I measure it. Alright, so I need to use a solution that I know to analyze it. Okay, so for example, so NaOH, okay, they can react with HCl. Okay, this is your alkali, this is your acid, and they react to form NaCl plus H2O. So the mole ratio here is 1 is to 1 is to 1 is to 1. Okay, so I want to analyze my NaOH. I will need to use a solution with known concentration. Okay, so for NaOH, there is 25 cm cube of it. To react this completely, okay, to react them completely, I realized that I actually use 25 cm cube of HCl. Okay, to react them completely, I realized that I use 25 cm cube of HCl. And I know that the concentration of my HCl is 1 mole per dm cube. Okay, so when these two react, they react with each other completely. Okay, so I need to find out what is the number of moles. I need to find out what is the number of moles here, and then I compare it with NaOH. Okay, so what formula should I use? What formula can you use to calculate the number of moles? Okay, now for NaOH, because I don't know the concentration, I cannot calculate. But for HCl, I know the concentration. I know the volume. Recall this formula. Concentration is equals to number of moles, okay, mole, over volume of solution. So if you see the unit, you realize that it's the same. This one here and this part here. Okay. I have my volume, which is 25. I have the concentration, which is 1 mole. So I fill it in. Okay, 1 mole per dm cube. Multiply by the volume, I convert it to dm cube. Okay, so 1 mole per dm cube reacting with 25 over 1000 dm cube of my solution is 0.025 mole. Okay, 0.025 mole. So from here, I realize that it's 0.025 moles of HCl. And this amount reacts completely with my NaOH. Reacts completely. Okay, so which also means that if this is 0.025 moles of acid, the number of moles of my alkali will also be 0.025 mole. So using this volume of acid, I realized that inside this conical flask is also 0.025 moles. So what is the concentration of this NaOH? Okay, so what's the concentration? So same thing, concentration is mole per dm cube. Okay, which is number of moles over volume of solution. Okay, now from the HCl, I calculated mole ratio. This is 0.025 moles. And then from here, because I use 25 cm cube, because this one I can measure. I can measure the amount using measuring cylinder, using burette, using pipette. So I know that this volume is 25 over 1000 dm cube. So when I do my calculation, this solution, the concentration is 1 mole per dm cube. Okay, so from HCl, I realized that I need 25 cm cube and I know the concentration. So from this known volume, known concentration, I calculate the number of moles of my acid, which is 0.025. I use mole ratio and notice that alkaline is 0.025 moles. Since I have the volume, I have the mole, okay, I use this formula, I can calculate the concentration. So this is what I meant by using the volume to find out what is the concentration of the unknown. Okay, so this is what we call volumetric analysis. Okay, so for volumetric analysis, I'm supposed to find out what is the unknown concentration. Okay, so I need to have a solution that has known concentration and volume. So my question to you will then be, then how do I know this acid is 25 cm cube? How do I know? Okay, from here I gave you. But in reality, how do I know it's 25 cm cube? I know the concentration, okay, because I need to have one solution with known concentration. But how do I know is this 25 cm cube? Okay, so let's take a look at this part here. Okay, so same thing, I'm going to have a solution of NaOH, okay, with unknown concentration, Okay, so I use a fixed volume. Okay, I use a fixed volume of this NaOH. I don't know what is the concentration. Okay, so I need to react with HCl. Okay, because from just now, I know that NaOH and my HCl is 1:1. So this HCl concentration is 1 mole per dm cube. Okay, so I want to react them together. But how much to react? Okay, so recall, this is colorless. Okay, this is colorless. So I must make sure that they react with each other completely, exact volume, so that I can calculate the number of moles of my HCl, and then I use mole ratio to calculate the number of moles of my NaOH. So if that's the case, since they're colorless, how do I react them together? Okay, and I don't know the volume of HCl. So how much to react them so that they are neutralized completely? So think about what you have done so far under salt preparation. If I have two colorless solutions, I want to react them completely. What must I add to allow them, okay, to tell me that, hey, stop reacting already? So I must add something to indicate that. So what should I add? Okay, if you recall, we add methyl orange. Okay, so I add methyl orange inside to color it, to have a certain color. Okay, so for my NaOH, okay, when I add methyl orange, it will appear yellow. Okay, because methyl orange, when it's red color, is acidic. When it's orange, is neutral. When it's yellow, it's alkaline. Okay, so I have my indicator inside. So I'm going to add my HCl. I cannot be using beaker, right? Because I can't really add it drop by drop. So what apparatus should I use to add my acid into this conical flask such that I can add it drop by drop and stop when I need to? What apparatus should I use? Okay, I will use my burette. Okay, so I have this burette. Okay, and then of course I have my retort stand. Okay, and then of course I will put my conical flask here. Okay, and then I have my NaOH. Okay, so I have a fixed volume of my NaOH and I have my acid here. Okay, so this acid is 1 mole per dm cube. Alright, so for my burette, for example, initial burette reading is 0.00 cm cube. Okay, 2 decimal place, 0.00 cm cube. And then I let it react. Okay, so I continue to let it react until I realize that my indicator changes color to orange. Then I stop because it's neutralized. Okay, so I look at my volume again. Okay, final burette reading, I realize it is 25.00 cm cube. 25.00 cm cube. So my question to you is, what is the volume of HCl used to neutralize 25.0 cm cube of NaOH? So what will you tell me? Okay, you will use the final, minus away the initial, and you'll get 25.00 cm cube. Okay, so what kind of method is this? The one with burette, the one you have conical flask, the one you have indicator. This method is called titration. Okay, so we are using titration to do salt preparation of soluble salts. To be specific, group 1 salt. We are also using titration for volumetric analysis. Okay, so from here, okay, I know that I have 25 cm cube of HCl. That's how I get the volume. And I know the concentration is 1 mole per dm cube. So together, I can calculate the number of moles of HCl. And then I use the mole ratio to find out the number of moles of NaOH. Okay? And then, using this volume here and this number of moles, I can find out the concentration. Okay? Now, if you don't understand this, I suggest you replay this part to understand. Okay, so this is what we call volumetric analysis. Using burette, okay, to measure the volume of my solution that I know the concentration. Then I use stoichiometry, mole ratio to calculate for the unknown. Okay, so this is what we call volumetric analysis. Okay, so for this lesson, we're going to use titration to find out what is the concentration, okay, of an unknown. Alright, so of course we will keep looking at concentration and need to recall what is exactly concentration. You don't have to memorize the definition, but at least understand how the unit come from, mole per dm cube. It is always the amount dissolved in a fixed volume. Okay, it's always the amount dissolved in a fixed volume. So it's always the number of moles over the volume of solution. And this is in aqueous state. Please do not confuse with molar volume. This molar volume, okay, is only for gases. When we say volume here, this dm cube is for solution. It's not for gas. Okay? So concentration, there are two types of unit. One is gram per dm cube. Okay? So mass over solution, volume of solution. Another one is number of moles over the volume of solution. Okay? So just now we look at what is volumetric analysis. It's a method to determine the concentration of a solution that you don't know. Okay, so the calculations are similar. Actually, we are just using mole ratio. We are just using stoichiometry. Okay, but let's understand. Okay, how is this volumetric analysis? Okay, so just now is the method. Okay, the method to do volumetric analysis. Now we'll take a look at calculations. Alright, so in this case, you are given this fixed volume and concentration of NaOH. So you know the concentration of this, you know this. Okay, but you don't know what is the concentration of H2SO4. Okay, so your job now is to calculate the concentration. So the first step is always to write down the balance equation. So acid plus alkali, okay, you will form salt and water. So I need to balance this. 2Na means I have the 2 here. So I balance this. Okay, so from here, I know that I have a solution of H2SO4. Okay, it is 25.0 cm3. Okay, so this NaOH, I have the volume. This is put inside a burette, and then they will react into the conical flask. Okay, since I have the volume, I have the concentration, I can calculate the number of moles. Okay, so concentration multiply by the volume, okay, and I'll get the number of moles. So using mole ratio, this is 2:1, okay, NaOH is to H2SO4 is 2:1. So if I use the mole ratio, number of moles, okay, if this is 0.0030, I divide by 2, okay, number of moles of H2SO4 is 0.00150. Do I stop here? No. Okay, question asks for concentration. Okay, question asks for what is the concentration. So I need to use this formula. Number of moles divide by the volume of H2SO4. Okay, so moving on. Number of moles divide by volume, I change it to dm cube. Okay, answer is 0.0600 mole per dm cube to 3 SF. Okay, so this is what volumetric analysis is all about. Alright, okay, so question, how do we know when to stop the reaction? So when I'm doing this experiment, for example, this burette, okay, this burette has my NaOH, and then this conical flask has my H2SO4. How do I know when to stop? Just now, what did I say? What do you need to add to indicate? Okay, you use indicator to tell you that it's complete neutralization, exact volume. Okay, you added exact volume to neutralize it. Okay, so titration tells us the volume. This is what we call titrant. Titrant is always in the burette. Okay, required to react with this unknown. Okay, so titration involves a solution of unknown concentration, and of course you need to have something that is known. So from the known concentration, you go and find out what's the unknown. Okay, so to perform the titration, recall a solution of the known concentration is placed in the burette. Okay, because I want to find out what is the volume. What is the volume required, okay, to neutralize. Then the one that is unknown, I fix the volume. I fix the volume. Okay, I fix the volume using pipette. Then I add a few drops of indicator. Now I want you all to think, why is it that I need the fixed volume? If I volume also don't know, can I calculate the concentration? Okay, recall, you will need the number of moles and you will need the volume to calculate concentration. If I don't fix the volume, will I be able to get the concentration? You pause and think about it. Okay, so step 4, I slowly add whatever that's inside the burette slowly until its endpoint. Okay, so titration usually involves acid and alkali. Okay, so for here, once I reach the endpoint, I stop the reaction. You don't need to memorize this procedure for volumetric analysis, but you need to memorize titration for salt preparation. You need to memorize titration for salt preparation. Okay, the one you referred in your salt preparation notes. Okay, so once I react them, okay, my endpoint is reached. It tells me that it's complete. Okay, so endpoint means the indicator changes color and neutralization is complete. So it permanently changes color means no matter how you swirl, how you shake, it will not go back. It will not go back to its previous color. Okay, so let's try some question. Okay, question 1, page 11. Okay, so page 11 of your notes. Okay, you are given this NaOH. Okay, you have the volume, you have the concentration. So this is your titrant, the one inside your burette. Then you are reacting with HCl, which is your unknown. This one will be in your conical flask. Okay, so why conical flask? Okay, this HCl is your conical flask. Actually, why conical flask? Why can't I put in a beaker? When you do your titration, recall when you do your titration, you always need to swirl this conical flask. Okay, you need to swirl this conical flask. So it's easier to swirl a conical flask compared to beaker. No splashing. Okay, so now what's the first thing you need to do? Recall step 1. You must find mole ratio, right? To find the mole ratio, you must write your balance equation. Okay, so my balance equation here, acid plus alkali, you will form salt and water. Okay, so this is equals liquid. Okay, so from here I know that the mole ratio is 1:1. So I have volume, I have my concentration. I always need to find the number of moles. Okay, so recall concentration is mole slash dm³ is equivalent to number of moles over volume of solution. Have this habit of writing the steps. Okay, writing the equation down. So I have my concentration, which is 0.1 mole per dm³. I want to find the number of moles of my NaOH. So concentration multiplied by the volume of solution, I need to convert it into dm³. Okay, so from here, the number of moles is 0.0032 moles. Okay, so now I know that this is 1:1. So if this is 0.0032 moles, this will also be 0.0032 moles. This is what we call mole ratio. Okay, so number of moles of my HCl is 0.0032 moles. I have the mole, okay, and I have the volume, okay, which is here. So concentration of HCl mole per dm³. So my number of moles is 0.0032 moles. Volume of HCl is 25/1000 dm³. So if I use my calculator and key in, I calculate, I'll get 0.128 mole per dm³. 3SF. Okay, so this is my part A. Alright, then of course, I want to find out my concentration in gram per dm³. Okay, I want to find out the concentration in gram per dm³. So from 0.128 mole per dm³, this part here, I need to convert to gram. So recall this formula. Number of moles equals to mass over molar mass. Okay, so I want to convert this, I want to convert these moles into gram. I want to convert them. So to convert them, I will need to multiply them together. Because I'm only changing mole to gram. dm³ stays the same. Okay, so what I should do is I will need to find out what is my molar mass of HCl. Okay, molar mass of my HCl is 35.5 plus 1, which is 36.5 gram per mole. Okay, So what I do is, I use my 0.0128 multiply by this. Okay, which means concentration of HCl in gram per dm cube. Okay, it will be 0.128 mole per dm cube multiplied by 36.5 gram per mole. Okay, I cancel away the unit. I will get 4.672 gram per dm cube. Convert, always round up to 3SF. I'll get 4.67 gram per dm cube. So this is how I do my working. Okay, so recap. I have this fixed volume of my unknown concentration, and then I have this amount, my titrant, to react completely. Okay, so first step is always to write the balance equation, and then I know that this is 1 mole is to 1 mole. Okay, so from this value here, I use this equation to calculate the number of moles of my NaOH. So 0.00320 moles react completely with my acid. So 1 is to 1. Okay, it means 0.0032 is to 0.0032. Okay, using the mole ratio, I can get this. So to calculate the concentration, number of moles divided by volume, I'll get 0.128 mole per dm cube to 3SF. Okay, part B. I want to convert it to gram per dm cube. Okay, I want to convert it to gram per dm cube. I will straight away use my 0.128, okay, multiply with my molar mass. So if you take a look at the units, okay, if you take a look at the units, actually they cancel out each other. So this is mole per dm cube multiplied by 36.5 gram per mole. So if I cancel them out, actually I'll get gram per dm cube. Okay, so you get 4.67. Okay, so this is how you do it. Alright, so let's take a look at the last question, question 2. Okay, same thing for question 2. I would like you to try out yourself. Okay, pause the video to try out yourself. Okay, so what's the first step? Okay, if you don't try, you will never know. Okay, because when you watch, it's easier than when you try. Okay, so try out now. What's the first step? Okay, first step is, of course, always to write the balance equation. So H2SO4 is an acid. I react with my potassium hydroxide, which is an alkaline. Hydroxide is always an alkaline when it's soluble. Okay, so to react them together, you will form salt and water. So I will form my H2O and I will have potassium sulfate. Okay, K plus, SO4 2 minus. So I need to balance them. I have 2 potassium here. So I must multiply this. Okay, so the mole ratio is 1 is to 2. So part A, you are given this. Okay, you know the concentration of my H2SO4. So I need to find out what is the number of moles of my H2SO4. Concentration multiplied by my volume. I must convert my volume into dm cube. So I divide by 1000. Okay, so if you look at the units, they cancel each other and you'll get number of moles, which is 0.00360 moles. Okay, so H2SO4 is to KOH, mole ratio is 1 is to 2. If this is 0.00360, KOH will be 0.00720. Okay, so I have the number of moles. So number of moles of KOH is 0.00720 moles. I have the volume. Concentration of KOH, okay, is mole over volume, dm cube. So number of moles is this, 720 mole, divided by volume. So volume is 24. Convert it to dm cube. mole divided by dm cube, I will get 0.300 mole per dm cube. Okay, so that is my answer, mole per dm cube. Alright, so this is part A. Part B. Now they want you to change it to gram per dm cube. So from mole to dm cube, you need to convert it to gram per dm cube. You multiply by your molar mass. Okay, so what is the molar mass of KOH? Okay, molar mass of KOH is 39 plus 16 plus 1 gram per mole. And you will get 56 gram per mole. So, calculate. My concentration is, so I want this gram per mole. So now I have 0.300 mole per dm cube from part A. From here. Okay. And then I multiply by 56 gram per mole, which is your MR. Okay. So I cancel the unit, and you will get 16.8 gram per dm cube, which also means it is 16.8 grams slash dm cube to 3SF. Okay, so this is how you get gram per dm cube. Okay, so this is how we use titration to find out what is the concentration of a solution. Okay, and we are done with both questions. Alright, so what's next will be to try out titration at home. Okay, so please go to this tiny URL. Okay, so it's just tinyurl.com/be patient with titration. So what is your homework will be to try out titration at home, okay, and learn to be patient. So slowly try out titration at home to really see the color change, see how to calculate, see how to record your readings. So when you go to the URL, you'll get this page. Okay, so click register. Okay, register your own name, register your own experiment. Okay, so you can enter your name, you can type your name, okay, and you'll get this lab report. Okay, this number, please remember. Write down your user number here. Okay, so I can retrieve it. So start only the titration 1. Start only titration 1. Okay, so another thing I would like you all to do is, of course, go to tinyurl.com/titration steps. Write down the steps on a separate piece of paper. Okay, when we go to lab, you will use your own procedure to try out the steps. So I repeat, to enter the lab, okay, you need your lab report. So to enter the lab, you need your lab report. It can be soft copy or you can print it out. Soft copy means you send to your own phone. Okay, and then your lab report together with your this procedure, only with these two, then you can enter the lab. So I hope you are excited for a lab when you come back. Okay, so what gets a chemist excited is titration, because you have to do a lot of things. Okay, washing, swirling, okay, pipetting, etc. Alright, so these are the additional resources. You can pause the video, write down the website so that you can go and take a look at it. Okay, so how to do titration, you really need patience. Okay, without patience, you will be very frustrated because you always cannot get the color. Okay, so yes, we are done with titration calculations, and if you have understood the lesson, you will know what this is. Okay, so titration is to always find out the concentration. Okay, that's all. Right, the next lesson, we'll take a look at limiting reagents.